Good morning, Professor. Our project focuses on the end-to-end engineering of a real-time big data pipeline. We choose to monitor Berlin's weather data, but the architecture is built to be industry agnostic. We implemented a medallion architecture with a bronze, silver, and gold layer on a distributed Hadoop clusters. This ensures that the data flow from a source to the dashboard. It is structured, cleaned, and enriched at every stage. Initially, we'll be starting by uh, starting the virtual missions. So we have started the 57 mission and the 56 mission. We could see that the status is running. So 56 our master mission. So we have logged into that. So the first thing we are going to start the hdfs with the start dfs.sh command. And we have to start the yarn with the start yarn.sh script. To validate the nodes, we are giving the JPS command. So we could be able to see the node manager, resource manager, name node, JPS, secondary name node, Spark submit, all are in running state. To explain about the ingestion layer, I'll give it handover to my teammate. Vishnu, Prethi, can you please continue from here?
Yes, thank you, YAAMINI. 1 second. So yeah, hello everyone. Today I will demo the ingestion layer, the producer and the Kafka. So here, as YAAMINI said, there's a master room and 3 worker nodes. The worker 2 node has the zookeeper and the broker 1. The worker 3 node has the Kafka broker 2. So first I will show you the worker node 2. Here we will be going inside the Kafka bit, and then we will start the zookeeper. So the zookeeper has been started. Now let's go to Kafka broker 1. I'm going to the next step. Here again I'm going inside the Kafka, and inside it I'm starting the Kafka server. Yeah, so broker 1 has been started. Now let me open the worker 3. Here I'm going to show you the broker 2, and I'm going to start the Kafka here. So now the Kafka broker 1 and broker 2 has been started successfully. Now let's we can check our worker 2's JPS here. So here it's the quorum peer main has been started, the data node started, Kafka and the node manager. So now I will be starting the producer, Kafka producer. For that, we need again to get inside the Kafka bin and then we will open the source. So the two brokers are running with replication factor 2. Before that, I let me show you the topic, Kafka topic. So the Kafka topic is already created for the weather. Second. So we will start with we have already created the topic, Kafka topic for weather, and I will show you the verification of that. So as you see here, when I run this command, there is a Kafka topic called weather row. So this is going to be our topic. Next, I'm going to test producer. So for starting the producer, I'm going to open the source BNB. And activate it. And then I'm going to run the Python file for the producer. So our producer has been started. So it takes at an interval of 10 minutes. So for each and every 10 minutes, the data will get loaded. Now we will use a consumer to get the data. So in worker 3, I am going to run the consumer code. So for this, let's go inside the Kafka then. And again, we are going to activate the VNV virtual environment, and we are going to run the consumer file. So as you see, it is fetching the data of the Berlin weather monitor. And again, it is a 10-minute update. So it will get the live update once for every 10 minutes from the producer. So here we can see the temperature, wind speed, humidity, how it feels like, the weather, the timestamp, and the hourly forecast.
Yeah, now we are in a nodes of a cluster, which is in nothing but in UI. Here we could able to see all the cluster details. So here we could see the active nodes is 4. We know that we have 4 nodes. One is a master node, and another one is a worker 1, worker 2, and worker 3. And here the node state is visible for us, which is nothing but a running state. And the last health update was checked on Sunday, June 18. And here the memory availability and memory used details, everything is here.
Start.
Okay, now we are in a step of processing engine Spark and Hadoop. So once the data is in Kafka, our Spark producer started streaming job takeover. So we are going to start the hdfs and yarn in a master. By using the start dfs.sh, we are going to start all the nodes on the master. We could see the name nodes had started and the secondary node also started. So we are going to start the yarn with the start yarn.sh command. We could see this resource manager is started and the node manager is also getting started. Once everything is get started, we will verify with the JPS cuff. So here we could see the node manager, name node, JPS, resource manager, and the secondary name node all are in running state. The next step we are going to do is about the layers, which I explained earlier. So now we are going to start the bronze layer, followed by silver layer and the gold layer. Before that, I'll explain what is bronze layer. So first, we land the raw JSON into HDFS. This is our source of truth for auditing. So next, definitely is a silver layer where we enforce a schema, we cast types, handle null values, and ensure the timestamp are consistent. This is where data quality happens. And the final layer is a goal layer, which is a business layer. So we don't just store the temperature here, we calculate the financial impacts. For example, we calculate the energy surcharges charges and the workplace safety risk in real time. Before starting that, let me change the HDFS to leave the safe mode, and I'm going to run the Kafka to hdfs.py script now, which will pull the data from Kafka. With this no hub command, I'm fetching the data from the Kafka with the Kafka to hdfs.py, and I'm going to append the command in the stream job.log. So the job got started. We can validate in a streaming job.log file by using a tail-f command. So we could see the data is getting printed. We could see the data is getting fetched. Let's wait for a few more minutes to get the script get completed. So the execution got completed. Let me come out of this log file. So I would like to run the run pipeline.sh command. Before that, I would like to say we have created a Spark jobs folder where we have listed all the files required. So I said initially we have a three layers. So we have created a three different script. One is a bronze layer, which is a raw to silver, and another one is a silver layer, which is a silver to gold, and another one is like a gold layer, so gold to influx. And so we appended all these .py with the run pipeline.sh script. So if we run the script, all these .py files will run in the background. So let me start executing this script and we'll see the live outputs here. We could see the step one cleaning raw data into silver layer has been started, and we could see the Java version and the Linux version here. It takes few minutes to get complete the execution. We could see that the goal layer and the dashboard linking everything in this log. We have also created a log file for this with the name of pipeline execution.log, where you can see the logs in live. So we could see the silver layer is success and it's going to the execution of gold layer, and now the gold layer is running on. We could see the goal layer got succeeded, and the final thing is like pushing the data to our inflex db. So the process is going on. Once we are done, we could see the success response here. Yeah, we could see that dashboard sync success, which is nothing but that the data has been sent to the inflex db. So the next thing is going to be about, so we have ran this pipeline.sh script manually, and we have automated this script for each and for every 5 minutes using the cron job. For each 15 minutes, the job will run in the background and the result will be appended in the pipeline execution.log file. So each 15 minutes, data will be sent to the influxdb. The next thing is like I'm going to show you the UI of the influxdb where data is loaded. We have launched the influxdb, and we are going to log in with the user ID and password here. In InfluxDB, we have a matrix named weather analytics. Under that, we have a weather matrix. We have a fields like an average temperature, maximum temperature, wind, and the city we have taken is a Berlin. And once we give the submit, we could able to see the trend. We can set it for the hours we want. We can able to switch the visualization as per our analysis. So in the dashboard, I have taken for last 3 hours, and we could see the value, the wind speed, and the temperature in this influx DB. As a continuity from here, now we are going to start the Grafana with the sudo system tl command daemon reload. The reload system will happen to recognize the new file. Now we are going to enable it to start on the boot with the sudo system ctl enable grafana command. Next, we are going to start the services with the sudo system start grafana. We have to make sure that the grafana has started, so we have to check the status again. We could see grafana is active and running. Let me launch the grafana with the SSL command. So it's going to be run on a localhost 3000 port, which is a default port. For the final sync, we choose influxdb because whether it's time series data. influxdb allows us to perform high-speed temporal queries much faster than a traditional SQL database. Finally, we connect to the Grafana. Our screen recording stop.
So we have come to our last part, visualization. So in the visualization, what you're looking at is the final output of our real-time weather analytics pipeline. While the backend architecture involving Kafka, Spark, and HDFS handles the heavy lifting of data ingestion, this Grafana dashboard is the operational control tower. It is designed to serve two distinct audiences: the data engineers monitoring the system health and the business managers making operational decisions. So let's go to the system health. Here we have ingestion data. So it's a throughput. So here we will get to know the ingestion rate of the data. The graph visualizes the volume of data points entering our system per minute. The spike you see represents the micro batch intervals where our Kafka producer polled the open weather API. So a flat line here would immediately alert us to a failure in the producer service or the Kafka brokers. Then we see the pipeline latency. The pipeline latency measures the time difference between the weather events occurring in Berlin and when it appears on the screen. In a high performance streaming architecture, we aim for sub-second latency. This proves that our Spark structured streaming jobs are processing micro batches efficiently without lag. And here we can see the raw Kafka ingress table, which shows the data of the Kafka table. So next, we can move on to the business impact. So as I said before, a lot of managerial departments would highly depend on business impacts. So first here, we are going to see the supply chain delay probability. So here the percentage predicts the likelihood of logistic delays. So we are not showing you the number, but we are showing you whether it's on time or it will be in a delay. So right now in this temperature, it shows on time. So it correlates wind speed with known trucking safety thresholds. A value over 60% would trigger an automated alert to the logistic team to reroute shipment. Likewise, it goes for the productivity and labor risk. So, productivity and labor risk metrics calculates the estimated lost man hours. For example, if the temperature drops below -5 degree, safety regulations mandate work stoppages. We calculate this in real time so project managers can adjust timelines dynamically rather than reacting after the fact. Also, here we see the weather intensity heat map and hourly average variations, which shows a huge difference between datas. So, finally, we can go to the operational status. So, here we show a different datas of the temperatures in Berlin. So the current condition right now is 2.50 degrees Celsius there, and the max wind is like 14.6 kilometers per hour. This is scaled by the Beaufort wind scale status, and it depicts that it's a breeze, and it will also depicts whether it is, yeah, uh, highly dangerous, or it's a breeze, or it's hot. So this scale depicts us this status. And then we have the wind strength to tell us about what kilometer per hour the wind goes, and the direction and speed radar. Here we also show the real-time temperature of from different days and the comparison of metrics. So, in conclusion to our project, in summary, like this dashboard demonstrates that we haven't just built a data pipeline, we have built a decision support system. It successfully ingests data from an external API, processes it through a distributed cluster, and serves actionable insight in a real time. Thank you for this opportunity.
Yeah, I would like to conclude this. So we
Yeah.
have combined the Hadoop storage, Spark speed, Kafka, and InfluxDB time series optimization. We have built a robust system capable of turning raw environmental noise into an actionable business insight. Yeah, thank you.